In this video today, we're going to look at a set of problems that involve a block on an inclined slope. So this problem has a mass block sitting on a slope that is making some angle theta to the horizontal. This block experiences two forces. Disregarding friction, the only force that is experiencing in this direction down the slope is the force due to gravity. This force is parallel to the face of that slope, so it moves in the same direction. This is the force of gravity pulling on that block, trying to move it down the slope. The other force it feels is the normal force, which is the slope pushing back against the weight of this block. So what we want to find really in these kinds of problems is the force due to gravity that this block feels, because that's how we're going to find the acceleration of this block down that slope. So the first thing we're going to do is we're going to recognize that this block has some weight mg. And this weight mg exerts itself in two components. We can call it the x and y component, but really if you were to tilt your head so that the slope is horizontal, you'll find that the weight exerts itself perpendicular to the surface of that slope and parallel to that surface of the slope. So these are the two component forces of that weight of the block M. So how do we relate this triangle that we've just drawn to the big triangle that we're looking at, which is the slope? So we know that, I should have drawn this earlier, but this is a right angle triangle. Great. And there's also another right angle here that in the triangle that we've just drawn. So if we look at this, we see that these triangles are basically the same, just in a different scale. We have a right angle, we have some angle, or two unknown angles. And if we match the right angles, you might have to do a little flippity-flip in your head, but you'll find that this angle here is also theta. Now you could do a little bit of trigonometry, or if you're good at geometry, you could also find that these external angles should add up to 180, and this angle minus that angle should minus this angle, and that should equal theta, etc., etc. But if you're not into geometry and you don't feel like chasing angles all day, you can just do a little bit of tessellation in your mind and you'll find that these are the same angle, theta. So let's now redraw this triangle we've just drawn a little bit away so that we can see it clearly. So mg happens downwards. This is important. And we also have theta and a right angle. So now we have a right angle triangle, and we're going to do some trigonometry to find the other sides. So to find the top right side, what are we going to do? We're going to do mg, and this is the adjacent side to the angle theta, so it's going to be cosine theta, because mg is the hypotenuse. And then the opposite side to the angle is going to be mg sine theta, of course. So mg sine theta is the magnitude of that force that's going down the slope. This is parallel to the slope. So really, this is the equation that we're interested in. Great. So if we were to redraw this slope again, angle theta, and there's a block on top, and this block is moving down the slope with force due to gravity, and we know now that this force due to gravity is equal to mg sine theta. How do we know that? Because this force is moving completely parallel to the force Fg that we've drawn in this diagram here. So we know that this line here is parallel to the slope, so therefore these two forces must be equal, because this block only feels two forces, force due to gravity and normal force. And so the force due to gravity, which again is a component of the mass, equals mg sine theta. Now, also, we can say that the net force that this block feels when it's just sitting on the block, the net force that this block feels is simply ma, right? And it also just so happens that the only force that is moving this block is Fg. So we can say F net equals Fg, because that's the only force that is moving this block. The normal force is perfectly balanced by what? By mg cosine of theta, which is the component of that force that is working perpendicular to the face of that slope. So there is no net force in the y direction. But in the x direction, or rather down the slope direction, there is a net force, which is the force due to gravity. So now let's equate these two. ma equals the force due to gravity. So the mass times acceleration equals mg sine theta. And now we see that the two masses cancel. So we're left with A equals g sine theta. So this is an interesting result. We've gone from the net force equals mg sine theta. We know that the formula for net force is ma. And we have rearranged and cancelled. And we are left with ag sine theta. So this is interesting. You see now that mass has no interaction with the acceleration that this block feels. Simply only the angle theta that the slope makes to the horizontal. So it doesn't matter how heavy this block is, it's going to accelerate at the same speed. If I, to use a wrong terminology, it's going to accelerate at the same rate as any other block that is sitting on the same surface. So, great. How do we use this now? So let's now use the problem of a block. I'm going to draw this triangle in the other direction now. There's a block now that is sitting, let's say 20 kilogram block that is sitting on a slope with an angle 30 degrees to the horizontal. Let's say now that this slope is 100 meters long. And if you're interested, you could use your trigonometric identities to find what these values are here too. But they're not important right now for this question. This question now is going to be, what is the final velocity of this block when the block is at the bottom of the slope? How do you find this final velocity? So the first thing we want to do is find the acceleration of this block. This block, again, only feels the force due to gravity happening down the slope. And we know from above that the formula for acceleration is simply g sine theta, with no mention of the mass. So for the sake of this problem, we're going to use for the gravitational acceleration to be 10 and sine of 30, which again, if you remember your identities, is equal to 1/2. So the final acceleration that we get is 5 meters per second per second. Great. So now we have acceleration. What is the final velocity? If you remember your velocity formulas, you have your final velocity squared is equal to your initial velocity squared plus 2 times the acceleration multiplied by the distance that this block is traveling. So this is your formula for finding any one of these 4 variables. In this case, we're looking for the final velocity. So the final velocity is equal to simply the square root of everything on the right-hand side. Right? If we square root both sides, vf squared goes to vf, and then we square root everything on the right. The initial velocity of this block is 0, because it's not moving at time equals 0. we're going 2 multiplied by the acceleration, which is 5, and d, which is the distance that it travels, which is 100 meters down the slope. So solving for all of this, put it in your calculator, and you'll get 31.62 meters per second as your final velocity. Once it's all the way down here, your velocity will be 31.62 meters per second. So this is how you'll solve a question where they'll ask you, what is the final velocity of this block when it is on a slope that is 100 meters long, and this slope makes an angle 30 degrees from the horizontal? Maybe they won't give you this angle. Perhaps they won't give you this angle, and they will give you how high this slope or this mountain is. Or simply you could do your sine or cosine or whatever side that they give you. Maybe this is, I don't know, whatever whatever that is. But maybe you can use your sine and cosines to find what this angle is so that you can find your acceleration. Good. So now let's flip the script. Now, instead of going down the hill, why don't we go up the hill? So again, we have a block now that was traveling down the horizontal at, let us say, an initial velocity of 14 meters per second. Maybe it's a car. You hit the slope. The moment you start on the slope, you stop accelerating. You take your foot off the gas pedal, and you're just going to see how long it takes for you to slow down and stop. So we have a block of mass m, and it's moving up the hill. And let's say that this hill is 25 degrees from the horizontal, the slope. And let's see what forces that this block is feeling. Again, the force due to gravity. It has the force that is the normal force. We're not interested in it right now. And we're looking for this direction here, which we will say, we will define for this problem as the positive direction. We'll say that this is the positive direction. So again, let's find the acceleration. The acceleration in this problem, because there are no other forces at work, only the force due to gravity, is again A equals g sine theta. By the end of this, you will not forget g sine theta. So this is 10 sine of 25, which equals, in this case, negative 4.14 meters per second to the minus 2. Cool. So the next question now is, what is the final velocity, or rather, what is the distance that it takes for this block to stop? And notice that I put the negative sign here for the acceleration because it's accelerating down the slope, but we have to find the uphill direction to be positive, so it has to be negative. So now let's find the distance that it takes for you to stop. So the distance, we're going to use one of our distance formulas, and again, it's the same formula that we used just before, where the final velocity squared equals an initial velocity squared plus 2 times AD. And now we know what the final velocity is. The final velocity is 0, because we want to find this when we stop. The initial velocity was 14 meters per second. We square it. Plus 2 times acceleration. Now it's negative. And the distance, which is what we're trying to find. So let's quickly open up these brackets. Minus 8.28 d. And then we're going to rearrange to find d. We have 196 over 8.28, which equals 23.66 meters. So somewhere along this line is going to be 23.66 meters up the slope, and that is where the block is going to reach 0, or velocity 0. That's where the block is going to stop. Of course, it's not going to stop for very long. It's going to start coming back down the slope, and we'll go back to the first problem that we solved. The next question that you might get asked is how long does this block take to reach 23.66 meters? How long does it take for this block to stop when it's going up the hill? Again, we're going to use one of your frequently used velocity equations. Final velocity equals your initial velocity plus how long you're accelerating at a given rate. So our final velocity is 0, our initial velocity is 14, plus the acceleration multiplied by time. Rearrange to find t, and we get 3.38 seconds as how long it takes for this block to not only stop, but also reach the distance of 23.66 meters. Now, next time, we're going to add ropes and tension to these problems, and I encourage you to look at that video, which will be on the screen now.